Thank you, David. Great. I think that David did a terrific job, I think, of framing the issues we hope to cover. As I said in my opening remarks, it is ambitious, but we have a day and a half. And I just want to reiterate, I think, the notion of the skeptical optimist. There was some discussion last night at the lecture about whether there's cause for optimism. And I think we have to have hope for good outcomes, but we have to make sure that we do what we can to make them happen. So let's dig in. I also want to give a shout out to Molly Wright-Steenson for her lecture last night, which I think was really terrific and was a great setup for this first panel, which is on how digitalization is changing the ways housing is designed and built. We have two presenters who we commissioned papers from. We'll hear first from José Luis García del Castillo y López, who's a lecturer in architectural technology here at the GSD. And his paper is AI for All, Perspectives and Outlooks on the Role of Machine Learning in Architectural Design. Following José Luis, we'll hear from Ivan Rupnik, Associate Professor of Architecture at Northeastern University, and he will present a paper along with his co-authors Ryan Smith and Tyler Schmetterer on modularization precedes digitalization and off-site housing delivery. Following those two, we will have comments from Elizabeth Christoforetti, who's an assistant professor of architecture here at the GSD, and Roger Krulak, CEO of Full Stack Modular from New York. So what we'll hear first, we'll have José Luis come up, and then follow that we'll have Ivan. And once they're done with their presentations, the discussants will join me and the others at the panel, and we'll go into our conversation. So with that, José Luis, the stage is yours.
All right. Well, thank you very much for that wonderful introduction, and I'm very happy to be here with all of us today. It's also my first public lecture in, I don't remember how long, so I'm very excited about that. Except for the fact that when I was invited to do this, I did not know that I was going to be introducing a panel on AI under the shadow of Molly's fantastic lecture yesterday on the ethics of AI, so good luck with that, Jose. So I'm going to take the shy route today, and I'm going to, instead of discussing the important aspects of AI, ethics, etc., I'm going to talk more about the role of artificial intelligence and how we design architecture. So I would like to talk today about where we're coming from, a little bit of what's happening today, and how do we use machine learning for architectural design, and perhaps throw some provocations on what do I see the immediate future of these technologies, how they will affect how do we design architecture, and in particular, the aspect of housing. So if I can, there you go. So architecture. So how do we design architecture? So if we go back in time a little bit, we can probably not remember the times when architecture was actually not a very structured field or a science, if you will. Architecture before the Renaissance used to be kind of in the hands of these people called the master masons who just showed up on site and they designed very ad hoc. They basically made a lot of decisions based on what they had around them, and things were changing and flowing in the construction site. It was very hands-on approach, if you will. And it wasn't until the Renaissance with the invention of the lineamenta that the revolution of coming up with a set of notations or drawings to represent in an abstract way architectural projects, it wasn't until the invention of these notational systems that the modern concept of separating how do we design and how do we think architecture from how do we execute and how do we build it. And it wasn't until this moment that this modern split of designing versus making architecture happened. A paradigm that has extended until our days today, whereas pretty much no one who actually designs architecture these days makes it happen. There's no architects who are also like bricklayers or like designs or create structures. That's not a thing anymore. So that modern separation about thinking and doing was also something that was at the core of the early reflections about how computers, when they started and when they became a thing, how we thought about how computers could change the way we think. And very interestingly, in the very, very early stages of developing computers, people were already advocating for the potential role that computers would have in bringing all this computational power, not for automating the design or the trajectories of missiles. That was not in their heads. It was about how computers could augment the way we think as humans, and how they could help us offload all these menial computational tasks like memory, like doing math, and let us focus on what's inherently human, which is creative thought, which is coming up with new ideas. That was also at the core of the first attempt to bring computation to architectural design, which was led by the aerospace industry and the automotive industry, and where the main problems was basically representing complex curvature in 3 dimensions, right? Computers seemed like it could be a good tool for doing that. But interestingly, very early on, it was identified that engineers who were making these computers for design identified that drawings were the main means for people in design teams to communicate with each other and to think through the design idea. So they asked themselves, how can we use computational techniques to significantly impact the way we think the design process? One of the first implementations was this machine that you see here, the DAC-1, whose acronym was, interestingly, Design Augmented by Computer, clearly representing the ethos of the time of how computers could augment the way we think and the way we design. Or the famous, you probably are familiar with this example, Sketchpad, 1963, the first system to allow us to touch on a screen, make drawings. But most importantly, what was groundbreaking about Sketchpad was the fact that it was the first computational system that allowed us to explore design instead of by setting what do we want, instead of setting how do we want things to be, like for example, let's draw this polygon, setting up constraints such as, for example, I want all the lines in this drawing to be perpendicular, and have the system automatically make them perpendicular. It was the first time that we could tell a computer what we wanted to do, as opposed to how that should be done. And this idea, the idea of designing through goals, as opposed to designing through rules, was probably the most groundbreaking idea in the 60s related to computers and related to design. To put this in perspective, if you remember from Molly's lecture yesterday, she was talking about the conference, Architecture and Computation, blah, 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 at MIT. That was in 1964, 1 year after the mainstream publication and access to all this. Sketchpad also was a PhD thesis whose title was not Sketchpad. It was a man-computer graphical communication system. Again, representing this ethos of humans and computers can work together and can augment each other. Unfortunately, that didn't really make it to commercial products, and how CAD systems evolved commercially in the decades after was not about implementing these new magical smart models of computation, but it was mostly about mimicking the old drafting techniques that we used to do in the analog drafting board and just making them digital. The reasons for this are multiple: recycling labor, unskilled, non-computational, literal. There's a lot of reasons for this, but unfortunately, CAD systems did not really reflect a lot of this new potential that computers could bring. Now, when it came to computer science itself also had a large revolution at the beginning, at the dawn of computation, because with access to all this new computational power, immediately came the idea of, well, is this something that we can use to replicate human thought? And then the first attempts to do that were, well, human thought is a really complex enterprise. So is there a way where we can break down a model of how do we think into single, individual, more approachable and more computational units, and then put them all together so that the emergence of all these tiny interactions may, through this interaction, may emerge more intelligent-like thought. And a lot of systems were explored, such as, for example, reward systems, adaptations, etc., etc. However, there's a long history about how back in the times, in the 60s and the 70s, this didn't get very far because of limitations in computer power, hypes, and then depressions leading to what's called the AI winters, etc., etc. But fast-tracking forward, it wasn't until recently, basically last decade, that new groundbreaking discoveries in artificial intelligence combined with access to strong computational power, and with the availability of large wealths of data, like David was talking about before, it wasn't until then that this perfect crucible of combinations led to an explosion in AI research and to this new spring in artificial intelligence that we're living right now. That happened mainly through the invention of backpropagation systems, a technical concept that we're not going to get into today, and leading to new architectures on neural networks and the concept of deep learning. The idea is that 5 years ago, 10 years ago, we've gotten really good at predicting things, such as music recommendations, what customers are going to want to shop on an online retailer. So all of that is already powered by machine learning. But what about creativity? What about coming up with new stuff, if you will? Groundbreaking inventions have also been done in this aspect. And the main one perhaps happened about 6 years ago with the invention of generative adversarial networks. Basically, think of this as an architecture where you put two neural networks in front of each other. One starts generating content, and the other one is designed to be able to discern whether if the content is true or if it's fake. And by having these two face each other in this kind of competition, it turns out that the generator actually becomes much, much better at generating artificial stuff out from nothing. GANs, generative adversarial networks, have become the core of most creative uses that we see these days in design, in architecture, and in the arts. Like, for example, recreating complexity in images or in songs from lower levels of information. For example, reconstructing color from black and white, or reconstructing facades, full facades, just from patches of labels, or even creating something from absolute nothing. You're probably familiar with the website thispersondoesnotexist.com, where if you go there online and you start refresh, you start being given new faces of people who do not exist. These people do not exist at all. So how does that reflect in architecture? Well, as I discussed before, drawings are the main fundamental means we have to communicate and to think architecture, and therefore they have become excuse me, the low-hanging fruit of how do we start designing with machine learning neural networks. Early attempts at this were done already in the 70s, and there were already computational systems to generate automated layouts of floor plans and even some 3D approximations of that. But again, fast forward into today, a lot of work has been done in the generation of floor plans, again with generative adversarial networks, from different sets of inputs. One of the most common ones is what's called floor plan segmentation of the idea of training neural networks to look at a floor plan and be able to figure out which use each one of the rooms will be having. Is it a bedroom? Is it a kitchen? Is it a living room? That has led to an explosion of floor plan-based neural networks. But the problem is that designing architecture is not a simple task, like the ones that machine learning is good at. An architectural design is actually a fairly complex task. So if we can do like they did back in the 40s and break down the architectural design process in smaller chunks that are more approachable, those are more digestible, and we can design neural networks to tackle those individual processes. Like, for example, do we have a plot of land? Can we train a neural network to predict what would be the best footprint for that plot of land? And then can we train a second neural network to figure out what the best partitioning for that blueprint could be? And can we train a third neural network to design what would be the best layout for furniture for that floor plan? And by daisy chaining them together, we can achieve results that are closer to the complex, multi-constrained problem that architectural design is. But also, it allows us to explore the full, vast, and rich design space of architectural design, all the possible combinations of floor plans that can happen from a variety or a collection of footprints. Now, the work that is currently being undertaken is actually much more interesting because it tries to connect floor plan and architectural generation more directly to the mental representations that we use to think architecture. So, for example, when I design architecture, I don't start right away with a floor plan. Sometimes I think literally, like, I would like a floor plan that looks like this and does so and so, and I use textual representation. Text to architectural images is something that is very heavily being explored these days. It's in its very early infancy, and today still requires a lot of contributions and a lot of additions from humans, but it's definitely something that will be happening very soon. As well, I don't know if you've ever thought, or if you do this yourself, when you design architecture, you think of diagrams of how things should be connected. In computer science, that is called a graph structure. And graph structures are actually very simple data models that have a very direct connection with machine learning. So can we design floor plans diagrammatically with connections as in the form of a graph and use that as early developments or early sketches of what of a floor plan of a building could be, and then develop that into full architectural expressions. Now, one of the problems that we're running into is that most of the neural networks that are out there currently being researched, they work with bitmaps, they work with images, and that is very simple because images are a super, super democratic way of representing data. We all have images in our phones, but very few people actually work with vector drawings like the ones that we use in architecture, so there's not a lot of research out there besides the one that we do here in architecture school, for example. The problem only gets worse when we go into full 3D, because in 3D, there are many different ways to represent three-dimensional geometry. We have NURBS, we have meshes, we have point clouds, we have voxels. All of those are very popular. And it turns out that the most popular ones right now under research are voxels, because they're basically stacks of images on top of each other. And they're also point clouds, because a lot of 3D scanning uses point clouds, and we have this wealth of data out there. Unfortunately, voxels and point clouds are a really, really bad data structure for representing 3D models. So there's a lot of work currently going on being able to come up with extensions of voxel representations and point clouds so that we can use those to create three-dimensional form, or to work directly at the level of meshes so that we can use these neural networks directly with this information that we typically use in architecture. But for me, the most interesting aspect is that it's not the 3D object itself, but it's the process that leads to 3D modeling. Because if we think about this, for example, in the 2D form, when we do sketches, if I would ask you to draw a cloud with some rain, most of us will actually follow very, very similar patterns. And because it turns out that machine learning, what is exactly very, very good at is learning patterns that are found in the data set, it turns out that machine learning models are getting really good at learning the processes, the sequential processes that we use for drawing 2D models and for drawing 3D models. This has been extensively researched, for example, for simple mechanical parts. How do we go from an idea to 2D sketches of a part, and the processes that we follow to then extend these sketches to 3D. So for example, I draw a line, I extrude it, I draw another object, I do a Boolean subtraction. Those are very, very common processes, which are even getting more interesting because there is a whole current of parametric design and people who are using Grasshopper, Dynamo, and these visual programming languages to explicitly represent this sequence of operations in 3D. And because they're explicit, those explicit representations are a really, really good suitable data model for a neural network to learn from. Lastly, there is the concept of bias in machine learning. You probably heard that bias is basically the idea that a neural network will replicate whatever patterns it finds in a data set. And in computer science, there's this term called garbage in, garbage out. If you give a model bad data, it will give you bad results. And if you give it unbalanced data, it will give you unbalanced result, which is at the core of all the ethics discussions about how machine learning favors several communities or not, etc., etc. But in architecture, if we think of bias, of the tendency to replicate a pattern as something akin to style, then all of a sudden it may actually be harnessed as a potential affordance. Because, for example, we can train neural networks and give them thousands of images of modern interiors, and then those neural networks will start replicating images of things that kind of look like modern interiors. We're still blurry, still not very defined, but this is going to get much, much better very soon. Bias and style is also something that is inherent in the architectural style, for example, of signature architects and the way they design particular buildings, always in a particular style. Or it's something that we can use as a design tool, as, for example, the concept of triple-deckers here in Boston that have a very particular technique and a very particular aesthetic, and how we can train neural networks to learn from those representations and exploit those representations as design tools. This is work from Elizabeth Christoforetti, who's going to be joining the panel as well today. Or the notion that this concept of style can be applied to urban environments, because at the end of the day, the cities already also have an image. They have this thing called the genius loci, I'm not sure how to pronounce that, or the spirit of the city, right? Which is typically conveyed through the image. So it's something that is actually very easy to harness if we were to think of design tools for urban environments where we can work with the 3D model representation in combination with different models of that urban spirit that we can think of. But ultimately, I think the real power of AI is as a creative partner on the loop. The idea that very soon, if not already, we're going to be working with AIs that are going to be in real time, giving us suggestions, giving us autocompletes, giving us, triggering our creativity and our inspiration as we are thinking through the design process. And this is very important because the suggestive role of AI in enhancing our creativity is what I believe leads to the expectations of the early dawn of computer science and how design and how computers could augment the way we design. Lastly, one of the real contributions that AI will bring to the design field is the fact that all of a sudden, people like me who know how to program will start being rendered useless. Because the idea is that machine learning is really good at learning from a huge data set without actually explicitly encoding the rules. So all of a sudden, the idea of gathering a data set, of collecting 1,000 images, is something that can be done by most people without technical expertise. And that, the embedding of a particular set of spirit or a pattern or a style by curating a data set will very soon become a form of programming in itself, one that actually doesn't require to know how to code a computer, and therefore democratizing the access to machine learning to everyone without the required technical expertise. So how do I see AIs moving forward in the short term? I think that obviously AI will be extremely helpful in the automation of the production of architecture, so all the menial tasks of like making drawings, laying them out, putting together documentation, diagrams, schematics, all that stuff will be highly automated very soon. Most importantly, I think our AIs will have an increasing role as design partners, so all this idea of the suggestive role of the communication within them, and specifically because we will be able to start designing based on goals rather than rules. We will start having the possibility of asking our neural network, I want this building to be prettier, or healthier, or more Gothic, or things that are not, they don't sound like computational things right now, but they will very soon, because we will have these possibilities. Obviously, architectural design will become cheaper and faster, hence probably being more accessible to wider audiences. And perhaps the one most important aspect is that I'm not sure that we are close anytime soon to a full-fledged AI that will design a whole building with one click, right? Because architecture is a very complex problem. It's one that is not a good fit for the narrow kind of problems that machine learning can help us with today. But if this happens, or when this happens, I am very confident that it will be housing, which will be the first field that will be tackled by fully autonomous AI that with one click will be able to generate one house. Because housing, with small cultural differences, is actually fairly common in the whole world, and the huge demand that there is for residential units in the world, combined with the relatively constrained design space that a house, most houses are pretty much the same. You can really get very creative. I think I'm going to get kicked out from this building from saying that, but it is because of this that I think housing will be the first feel within architecture to be fully automated by AI. Programming by curation, as we discussed, and the possibility that more people, by curating these data sets, will be able to train their own neural networks and contribute them in these new forms of marketplaces that will be embedded with AutoCAD, Revit, et cetera, et cetera. Just a final thought. There's all this conversation about how AI is going to displace architects and how humans are going to be rendered useless. I just want to highlight the fact that I'm not sure this will be true anytime soon because, as I said before, machine learning works because we train machine learning with particular data sets. So at the end of the day, there's always a human that has some degree of agency behind the actions of any neural network. And keeping that in mind, not just to keep our agency in these processes, but also for issues of not liability. What's the word? Accountability, and agency. I think that would be very important to keep in mind. And with that, sorry, I think I went over time. Thank you very much.
Oh, wow, that was smooth transition. This is definitely the GSD. Great. And the advanced. Big green button. Yes. The big green button. Okay. Well, thank you, David and Chris, for inviting us from ModX. I'm the only representative today, and for the feedback we've already received, which is going to be included in this presentation and has not made its way into the paper yet. So today, I'm going to argue that to increase the quality, affordability, sustainability, equity of housing delivery, modularization will need to precede digitalization. And actually, just from discussions from last night, I would also add that data culture in construction will need to precede digitalization. And in fact, that modularization, thanks to discussions even this morning, is a form of analog data culture that is missing in construction and in design. So who is ModX? Before I get started, ModX is myself, Ryan Smith, and Tyler Schmetterer, and we work as researchers, as consultants to help structural change in the built environment through the use of off-site construction. And so why are we talking about off-site construction today in this space, in this country, in the world? It's not new. As Molly alluded to, you might look to Ohio, but you might need to look a few years earlier. In 1917, we have very large-scale off-site fabrication of housing in the US, actually using analog digitalization tools. So we've had it in this country for 100 years, and yet it still has not really caught on. And some of the explanations have to do with actually recent knowledge that we've acquired. So I would love to say that I've done this research. I'm very jealous of this research, but the McKinsey Global Institute did a real favor to everyone in 2017 and has had an impact in Silicon Valley, in Wall Street, as well as in places like Washington, D.C. and Brussels by showing not that offsite is a solution, but that construction has a serious problem. And the U.S. has one of the worst construction problems. We have lost essentially half of the productivity you had in 1968. It takes us twice as much effort to do the same thing. The industry has deindustrialized, and in the context of this conversation, it's also de-digitalized or de-datafied. Industry increases data culture. As industries deindustrialize, they also de-datafy. They're not causal, but they're related. So to digitalize, we need data. Construction does not have a data culture. And so again, I'd love to have made that argument, but I'm glad McKinsey did, and we can do our work further going on. So McKinsey, in their report, also did a good job of saying that, hey, innovation and technology are important, manufacturing is important, but hey, there's a few other things we need to change, contextual things. We need to change regulations, contracts, we need to rethink design, which is what I'm going to talk about today. We need to do all of these other things, as well as to infuse technology into the construction sector. And we can do that by moving to a manufacturing process, but if we don't do our homework and eat our vegetables, we won't get there. So the other point that's important is the U.S. has not only had off-site construction for 100 years, we've had fairly large market share of off-site construction. We haven't studied that because it's not always sexy, but the trailer home industry or the HUD code industry had as high market share as 33% in the single-family market in the late 90s, and it still holds about 10% of that most ubiquitous American housing type. So with all of its challenges, the policy regulations, the innovations that led to that should be studied. We're trying to study them. And the volumetric modular industry, which in many ways grew out of the policy changes that supported manufactured housing, has between 2.5% and 5%, depending on how you cook the data, which is not reliable. Just keep that in mind. And still has a pretty significant market share without some of the regulatory support. So we have it, but we still, if we look back, and we have digitalization leaking into the industry. So Revit is being purchased by offsite companies. So there is BIM in the industry. But if we look back at those technological innovations, the appearance of HUD code, CAD, CAD/CAM, and BIM, the production keeps dropping. So why is that? We think, for one, we need to change the context. The context is important. And when I say context, I do mean the social and cultural context, but also social and cultural context in modern societies are reflected in things that you guys in this group know well, is in the regulatory frameworks, in the institutionalization of contracts, and again, in data culture itself. So that is something that needs to change before. So what we've been doing is we've been working as ModX with trade associations like the Modular Building Institute, with NGOs like the Construction Revolution Group in Minnesota. Shout out to Mary Tingerthal. And fortunately, we're very proud to be working with people like Carol Galante, who is in the audience, with HUD, who is very interested in understanding its own history in impacting positive change in offsite, but also understanding the history of other places that have actually learned from us, and we have not learned from them. So countries like Japan, much of Europe, have studied offsite not as a technology, but as a series of contextual changes in this country. In fact, we've learned more from their perspective on the US than we have often through this country itself. So contextual change is happening. This discussion, though, will be about what's next for ModX, which is rethinking design. We do need to also rethink design in a broad sense in housing if we are going to see the benefits of offsite construction and the benefits of digitalization. That has not happened yet. So the paper, and I'm going to not get into all the case studies in this discussion, but they're going to be in the paper. We need to rethink design through concepts that have brought that success in every other industry that has increased productivity and has been able recently to adopt digitalization techniques, but has had data culture for 100 years. This is what my doctoral dissertation was about. We've had data culture since the 1920s. We've lost it in architecture and construction. So before digitalization and even industrialization and circularity, which is something I'll touch on from Japan, which is also innovating in all three of these, can happen, we need to change the design of housing, and we need to change what design means. So we did not invent, like we did not invent McKinsey's excellent diagnosis of the problem, we did not invent these terms. They've been around for 100 years, along with offsite construction. They've been called different things. Today, the key concepts here are called modularization and product platforms. Modularization, to quote a Swedish firm that works in this space, is the activity of dividing a product or systems into modules. Those could also be AI programs, those could be objects, those could be processes. It's flexible, so as to create different requested configurations while reducing the number of unique building blocks. By reusing module variants across multiple configurations, economies of scales are reached. Without standardizing the product. Sorry, very important point. Without standardizing the product. So product platforms then are kind of families of modules, and not modular. Modular, by the way, is not always modularized. Just to be clear about that in the U.S. context, are collections of modules that are common to several products. This commonality is developed intentionally, so it's designed to achieve desired effects and to create value. And then, in a little bit of a cue to my discipline, architecture, a product platform can also be understood as a game with finite but flexible set of playing pieces, like a set of dominoes. You know what I mean if you're an architect. Product platforms are not products. And modularization is not productization. That's a little bit of an internal industry conversation that we can get into. And this is some of our summaries as ModX. Product platforms enables an economies of scale, not because of the standardization at a product level, but because of standardization at the module or subassembly level, and which allow variety at a product level. So we see this working incredibly well, whatever we think of, the products themselves, in every other industry that's been mapped out by McKinsey. So our smartphones do not use this principle to manage the subassemblies of the product, but also the territory that supports that product, the sales experience that supports that product, the degree of variance that a client is willing to pay for, and also all of this feeds into a process of continual improvement, or as I talk about it in my dissertation, continual evolution and adaptation, where products are not designed by any single person. They're also not designed by an AI. They're designed by continual interaction of real actors in a space. So our phones are designed by us, truly. Right? Same thing also allows for collaboration between competitors, which is something that also Le Corbusier, by the way, talks about in 1920. So one great example, the ability for a company like Volkswagen to integrate electric batteries into their product platform is because of the same design principles. And even more interestingly, for Ford to be able to purchase this IP in a reasonable way and also disseminate that innovation is something that happens regularly in every other industry and is almost impossible currently in the construction and AEC space, because we do not use this design process, and therefore we also do not have regulatory frameworks, codes, and standards that support that. Perfect. So when we walked into this factory in Japan 8 years ago, by one of 8 factories of Sekisui Chemical, a large volumetric modular home builder that also happens to be a manufacturer, we were surprised first by how much it looked like a car factory. It's taken us 8 years to realize how much it's designed using the same principles and how different it is from a car. So we're not going to go into this in detail, but the first thing we did with this company is to understand its cultural and regulatory history before we get into the technology and before we understood the design principles. Not going to go into that here, but it's important. We also discovered that while this process currently does not need an architect to design, it was actually designed by an architect, Professor Katsuhiko Ono, whose work was actually explained to us by his protege, Professor Shuichi Matsumura. So this product platform was designed by an architect. The territorial logics, the supply chain was designed by an architect, and over 500,000 housing units have been delivered using this system, no two of which are the same, each of which has improved continuously. It has a light gauge steel variant, has a wood variant. The principles are the same. Like the Argos in Greek myth, all of the relationships of the parts are the same. Every piece has changed and continues to change, both at the regulatory scale and through each deployment. So the company actually has lifestyle brands that people confuse for models, for model homes, but in fact, those are there just to give clients a sense of what's possible. In reality, each house that leaves this factory is unique because they have not standardized the product. They have standardized the subassembly using modularized product platforms. So there are 90 pre-engineered structural chassis and 60,000 predefined subassemblies in this digitalized system that was initially designed in an analog way and has evolved in over 50 years. This is how it allows them to also manage their fabrication logic, both at the scale of Japan and at the scale of their 8 factories. In fact, each factory is divided between a space of actual fabrication and a space of dry assembly. The degree of what they make inside the factory or inside the company and outside changes year by year, decade by decade, is very strategic, responding to opportunities. This is the same system, and actually Ono's original design, the company didn't use this initially, has allowed the company to also recycle these houses, to offer a lifetime of services to their clients because of the same principles, because they know these houses are actually digitalized, they actually are datafied, they're data rich, and through that data, It makes them easier to recycle. It makes it easier to do what is actually valuable in the industry, to provide services, not just products, to your customers. And so in the paper, what we're doing is we're also doing the homework that we've been given, which is to explain what is the digitalization strategy. So in this case, Sekisui is using custom software that they've developed alongside this process and is embedded into every part of this process. So just quickly, another example, not that, Japan is doing this. A lot of companies in Northern Europe, particularly in Sweden, have done this approach. Volvo has been involved. There is that knowledge transfer. So Lindback's big, the company that is literally doing the most standardized, which is not to say standard, mid-rise for Roger and the audience product in the space. They're doing up to 8 stories plus podium of light frame construction. Think about how affordable that is in this space, right? Within the Swedish context. Same thing we've done, and again, love to go into it, but understanding the history of this company, how it's evolved, how it's funded. This increase in capital-intensive work is important. Understanding how it's participated in the change, not just in its company, but in the regulatory framework of Sweden and Europe is important, but for another time. What's important here is, again, both Japan and Sweden in the 1970s, during the last energy crisis, not the one we're about to get into now, imported American frame construction into their building cultures. They did not have that. They imported it because it was literally the cheapest, most standardized form of construction they could find. And since then, they've really improved on it. So our typical volumetric modules in the US are the key subassembly with which we organize space and production. In Japan and Sweden and pretty much everywhere other than the US, the subassembly panel or components are what is standardized. Volumes are not. So in this case, in Lindback's system, the volumes are not standard. The wall panels are. And so this allows for floor plan flexibility. On the left is actually a Cambridge project, I'm not going to say which one, where the mods are the subassemblies. So you actually have the worst case combination of a non-standardized subassembly and an inflexible layout. In Lindback's, the opposite is the case. You have a highly standardized subassembly, highly flexible floor plan. Lindback's is built around 10 standard panel types with a lot of parameters. Every stud is a parametric element. They've also done this kind of thinking at the factory level. They've continually improved. They've taken their own old forestry products factory, turned it into a panel factory, then turned it into a volumetric factory before they ever invested in a customized, highly digitalized, highly automated factory, which they just completed recently. And this, I think, as we're getting to the conclusion, that at the source of this, here's Helena Lidlow, who has been our mentor in the Swedish space, and who is now actually in the US, and I'll speak a little bit more about that. Data culture has been key to this, analog data culture. Essentially what we call community engagement in the architecture space is actually how successful companies also work. And she built this culture, actually Swedish companies built this culture in an analog way before digitalizing it. So just to make that point again, and that kind of continual feedback, which actually was theorized very much in Boston by people like the Gilbreths 100 years ago and was very much tied to data culture and modularization, is still what makes companies successful in this space today. We'll also be, in the paper, we're also going to be breaking down Lindback's use of what more typical digital technologies and how they show up in their project delivery process. So in Lindback's case, architects use conventional modeling, whatever they want, and deliver a set, and then Lindback's essentially reworks it within their own design department using a new program called Vertex. It doesn't matter, but we can talk about what a software that is not, that does connect fabrication and design in a way that, unfortunately, in the US, we do not have products with the exception of a very expensive CATIA to do. So this is changing. So this is also coming to the US, and we can criticize all the problems of Katera, but they did some things right, that all of the things we've described were being applied to Katera's business model. There's a lot still more to learn from, and the obstacles they have faced are the obstacles we should be understanding as well. The term AHJ, for anyone who knows that term, is something we need to discuss and if we want to see the benefits of this. But also just 2 hours down the road, another company you can visit or watch on this old house is Benson Wood. So in a very gradual and incremental way, they have adopted the same process. They brought in Helena to teach them about data culture. They understand that a lot of people, they've traveled, surprise, surprise, and seen that, gosh, Sweden uses American construction, but in a way that is compatible, but also innovative. Why don't we try to adopt that in a country that it actually uses 90% light frame construction, as opposed to always reinventing the wheel? And just last week, I was visiting a classmate of mine from the GSD, Gordon Stott, who has brought in a former manager of supply chains for Apple, Greg Leone, to set up an interesting approach for single-family ADUs and homeless shelters in California, Connect Homes. They've been around for 10 years. They are still in the analog process of building data culture, but they are building data culture. They are building a modularization strategy. They are building product platforms. And when they decide to automate or digitalize, that platform will be there. So just in closing, we've been happy as ModX to sort of foster some of those relationships. So Helena Liedlow, who has really been I think a key figure in this space, unfortunately not always recognized in the US, from Lindbach's, has just made her way to VBC, an American company. And we were happy to kind of help both VBC and Lindbach's see what was going on in Japan in 2019. So this is us touring with what was then Katera, Lindbach's shop, and Polcom, who has also now been acquired by BBC, and really understanding how the Japanese have solved a lot of these issues for us in ways that are fairly straightforward and maybe we should look at. And so just in concluding, technology, digitalization, automation are really important tools. This idea that is used by every other industry, modularization, product platforms, and continual improvement, are a necessary step between the reworking of the context within which we deliver housing, which is happening and will continue to happen, and we need all your help, and the future of how this technology will help to produce more equitable, sustainable, but also higher quality housing for a fixed price. Thank you very much.
Well, great. So Jose Luis and I have a really great information for us to chew on. And then we're going to start by having Elizabeth Christoforetti from the GSD provide some of her commentary. And then we'll hear from Roger Krulak from Full Stack Modular. And then we'll begin a conversation among us. So Elizabeth, welcome. Good to have you here.
Yes, thank you. That was really fantastic. And two very different perspectives, which I really appreciated. So I wrote down some notes, and hopefully it'll hang together. I'm going to talk for about 5 minutes. So I liked, Jose Luis, your comment about housing as being a sort of tip of the spear in a way. Housing is kind of this litmus test for these larger changes because it's so unitized, it's so vastly needed, and it's potentially the most scalable and replicable type, right? So it's also the architectural type that sits closest to public infrastructure. Is it something that we have a right to have, right? So now we have this conversation from Molly from yesterday. So this tension between public service through delivery and relevance or quality, on the other hand, for changing modes of living and being in culture, kind of what we do here in the design school, how do we make things that are relevant for 21st century life and for the people who are really needing the units now? They're changing. We have multi-generational households, different modes of living, so on and so forth. Because the need is so vast and so pressing, the private market is also interested and, of course, very much needed. But urban change tends to look like this because of regulation and because we're complicated, because we should be, we're humans. Whereas private market requires kind of this level of change. It requires fast change for fast returns. So there's a kind of disconnect there that I see as a tension potentially between what you all are talking about. So potentially here a conflict between the potential of frictionless technology and the complication of human culture, and maybe this is also something about the demise of Katera. So in José Luis, I see the potential of a new mode of creativity and urban quality, an era of human-machine collaboration that promises greater cultural sensitivity and relevance, using ML, machine learning, and AI to see better, to actually understand the world that we don't always look at within this school. We look at a canon, but actually there's a lot more there, and we can see it more sensitively using wider data sets, and potentially to make new and more relevant design. So this is the sort of design apologist perspective. And Ivan, I see the promise, of course, of digitization for greater yield and efficiency. If only we can overcome this tiny social problem and political problem, dare I say, of standards. So we're back to Molly. I don't know where Molly is, but we're back to Molly's question from last night, the question of values and ethics. So I'm going to try to spell out sort of 3 different value systems that we might put on the table that are sometimes overlapping and sometimes diverging. The first is more housing for more people. This is actually a quantitative need. This is something that the public sector, of course, takes on, and we need it to take on. On the other hand, we have the second value system, which is something about driving profit through efficiency, so filling a needed gap in the market. This, of course, also is quantitative, and it's the job of the public sector. And then thirdly, more relevant and better housing, so and possibly even delightful, relevant, sensitive, accountable to the populations that are changing within our society. And these are things that aren't necessarily separate from each other, but they can feel quite separate. And I can say from the position of this building, it feels incredibly separate sometimes. Like we're not even having the same conversation. So my interest here in this conversation is how each of you are observing, or maybe not observing, I suppose, the breakdown of these silos, these 3 things, in order to provide a relevant and effective platform of values for scalable quality in housing. So how do we balance the need for more through efficiency and fintech, right? Somebody's got to fund these things, with things like accountability, sensitivity to culture and context. And so I'll try to package this very long-winded thing that I just said into a very small bite. My question, what is needed for an agreement around standards, and who should lead, or maybe who should get the funding? The funding's out there. How do we decide where it goes, and how do we decide what the tip of the spear is when we're pursuing digitization in housing? And Roger, I'm sure you have many opinions too, so I don't want to leave you out in this.
Thank you, although you may have. But anyway, I think I'll make a few comments. Think of myself as pragmatic and rubber meets the road because I'm doing this modularized manufactured housing on a regular basis, and a bunch of things that were said. First, start with José Luis, that are very interesting to me, and actually I want to maybe challenge. So early on, you said that the master masons of way back when were the ones who actually put together without any real drawings or really any information, and I know that that's true, and then emerged sort of architectural design and some schematic idea of how it wanted to be manifested, et cetera. And somehow in the process, as Ivan described, that's happened to deindustrialization of construction, design's sort of gone the same way. So because of the regulations, because of the insurance and liability requirements, the reality is that most design today may be prescriptive, but it isn't definitive. So most of the people doing the design of the pieces that go into a building are the electrical contractors, are the mason contractors, are all those people. So they're taking all of this prescriptive information and they're trying to manifest it in a way that is very interpretive. So we're sort of back towards the mason is sort of figuring out how to build it. Or I think about
design it,
and redesign it,
including drawings. Yeah.
So I think about at MoCA the architectural exhibit where what's his name, Anyway, he basically lists how everything is supposed to be put together by giving dimensional accuracy of something, and then obviously it gets recreated over and over again because they're huge murals. But the reality is that how it happens is insignificant. And I think that we're sort of back to there, and that's it's somewhat disconcerting. But I think that that's an interesting question I have, is like, where are we there? And I think the other thing you talked about, with tools for artificial intelligence, et cetera, one of the things that's interesting about the idea of industrializing something is that not only does it have the standard, you said houses are pretty normal. I do mostly multifamily design, they're even more normal. I mean, the parameters that exist before you think about modularization are incredible. Like, if you follow all those rules, you can only do so many things. And so one would think that you could take the design team, the engineering team, we'll talk about the government in a minute, and then create something that is pretty flexible, pretty interesting, and that provides agency, but at the same time, even those parameters already exist, the computational model sort of doesn't really happen. And it would seem to me that that would be something pretty easy to achieve, right? It would be pretty easy to achieve a set of tools that you could say, okay, go ahead, create a modular, create a multifamily building that meets all these needs, including cost effectiveness, et cetera. Should be simple, but we have some work from a silo perspective to do, it seems. And Ivan, so much to say, but I think the biggest elephant in the room, obviously, is that we're in an environment where regulation, where industry standards, the fact that almost all of the trades are designing what's actually happening
on site,
and sort
without
of
the skill of a master mason. Sorry,
exactly. That's all good. And fear of loss of agency. And I've spoken, 5 or 6 times here at GSD, and every time on alternative project delivery, and I will get very excited about which student is going to ask me about how they lose their agency in the process of designing a modular building, which I love. I say, multifamily buildings, I don't know about agency, but you have a whole bunch of parameters you have to follow to start with. But I get a kick out of it. I think it's fantastic. But it is a challenge on how to figure out how to collaborate and share that process with end goals in mind, and they're defined, and whether that's affordability or volume. I mean, we need so much housing, it makes my head spin every morning when I wake up, and at the same time, they're not getting built. So what do we do about that? And then, I want to sort of have you clarify something, because it is true, I understand that the sub-assemblies that you're talking about, the modules, are product.
Their modules are not volumes.
Right. The productization of the sub-assemblies associated with building something are still productization. What I think what we're saying is that the productization is not necessarily the volume itself, but the pieces that go into it.
Important point.
Yeah, hugely important point. And I do think that you're seeing, can you sort of predict how the industry evolves in order to incorporate that here in the United States?
Well, you're doing it, so.
I am a little bit, but but it has to. But me is not an answer, right? So the answer is that what are the products, and so does my chassis system need to be promulgated all over the world, because we created something that's a little bit better or a little bit more interesting than anything else, and where else can we incorporate that? So those are some of my thoughts.
Well, terrific. I want to, offer Ivan and Jose Luis, do you have any response off the top, or we can jump into questions? Jose Luis, do you?
Oh boy, I think I'm going to get fired after this conference for the things that I'm going to say. Well, I have a lot of thoughts. I want to make sense of them. So for me, the concept of the problem, or the concept of agency of who is going to live in a particular building, to me is of utmost importance, because I think I come from a different background. I grew up in Spain. I went to architectural school there. The industry is very different. It's not so standardized, so not so modularized. A lot of construction is basically concrete and brick and mortar, which allows itself for a lot more flexibility and freedom. There's not so much modularization. So that's one thing. But also, I grew up in a culture where some of my parents' friends were making themselves houses, and they hired architects. And I heard all these crazy stories about oh, I can't get my architect to design my house the way I want it because he just has this idea and he just wants to go for this idea, whatever. And I was like, how is this person designing this thing against your will? And you have to end up firing this person. How does this happen? And then I get into architectural school. I'm really going to get into trouble here. I get into architectural school, and then there's this notion of like the architect, and we solve society, and we're like these heroes or whatever. But then you barely do. For example, when I went through architectural school, I barely did any housing project in studio because housing was seen as, you know, this problem that is fairly easy, like it doesn't have a lot of creative space, whatever, whereas is the utmost important form of architecture that you're going to be mostly building throughout your career. So for me, that was, I mean, I was not able to reconcile many of those things, and that's probably why I ended up in computation, and I'm not a practicing architect of sorts. But I think some of digitalization may bring some of those answers and may bring some of that agency of decision-making back to the people who are going to be living in these houses. For example, I think modularization is basically a form of, as I said in the lecture, like breaking down the problem of architectural design into smaller units that are more digestible, not only for machine learning, but also for humans who are not trained in architectural design. If designing a house is not navigating the vast, complex design problem of an architectural object, but it's about choosing from a discrete set of options with this Lego model that you can assemble, whatever, then all of a sudden it's something that is more accessible to wider audiences that have not been trained in architecture, who arguably should be part of that decision-making process. That's one thing. And then obviously, like, we throw some machine learning in there. We have some algorithms that help regular people click a bunch of things and then come up with a full-fledged design that they just can run by an architectural firm and get a sign-off and then build it. That, again, is a game changer because it brings back decision-making to the people who are actually going to be living there, which, again, for me, when I grew up, was a no-brainer. This is how things should be, but then the industry and the practice led me to believing that that's not how it works, you know, which was a very, I don't know. So I don't know if this made sense. No, but this might be my last words as a teacher in this building.
Jose Luis, I really do hope that this is a safe space. And just a couple observations. One is that, you know, it's interesting, the connections between your talk and Ivan's, when, you know, what you just described in terms of breaking this down to small pieces. I was sitting next to Ivan, his head was nodding like that as well. It's exactly, you know, then in his describing the Japanese factory, the Swedish factory, and doing exactly that. The other thing that struck me when you were just describing the kind of the role of the architect and the client in Spain, it reminded me of your talk about, you know, the human's relationship with AI and the computer, where you're describing that we're changing it to saying goals. We'll tell you the goal, and then then the AI will say how to do it, which is, in this sense, really what the architect's role should be, where the client says, here are my goals, and then the architect has the creativity to define it, as opposed to what it sounds like is the architect saying, no, here's what the goals should be. So there's actually some interesting parallels. Ivan, I'll give you a chance to respond.
I'm going to pull this out. Can't wait. So starting, I think, actually Elizabeth's point, which, you know, we probably talked about other times, and it actually relates to the comments around Spain, which is that the issue is not so much that there are just silos and who should lead, but that, let's start with like an AA. Let's admit we have a problem as architects, since three people in this audience are architects, or some are registered, some are not. And I actually think a lot of the problem that architects have is unintentionally alluded to by the story, the story instead of history you told about the history of architecture, which is that somehow there was a master builder that was, impromptu figuring things out on the site and was replaced by a thoughtful architect specialist. That is historically not true. In fact, master builders, the reason that they could improvise on site is because they had deep modularized knowledge. They knew exactly what the timber was going to be in the site. And in fact, many cultures have been telling the opposite of the story you just told, including your culture, Spain or Portugal, which says that architects actually lost agency in the Renaissance. In fact, that was the kind of core discourse in the early 20th century when we were actually involved with industry. And that industry was a chance to return to a more informed architect, one that had knowledge before arriving to the site and one that could be more engaged in the site to provide value and engage with a broader set of groups. So it's actually the opposite. And I do think, and just to be even more contentious at the GSD, that model of education and architecture, from my experience in Mod X, where we don't work with architects, is that one, architects are not prepared to have not a leadership role, but any role in this process. But on the other hand, we need architects. Katera needed architects, or what we once called architects, because they're not being trained anymore. They're not being trained to think like a master builder and to understand and map out or cool hunt the kinds of systems that exist. Whether Roger's chassis is a good one or not is a skill that we do not teach anymore. We teach the story that you showed us, and it is not a productive story. It is a disempowering story. And it's not the way, architects are taught in Portugal and Spain, where even when you have a system that is not industrialized, the architects actually think about what builder's going to build it. The idea that you would draw something like I did when I worked on condo buildings in New York City, and it went from steel to concrete to steel to concrete 10 times, and of course made the productivity of the set a disaster, is something that doesn't happen in the rest of the world, whether you're working with industrialized systems or not. So, the education of the architect is a great place to start, and is a great way to not be responsible for that productivity drop that we see that McKinsey has identified. And by the way, 1968, education in America changed too, along with contracts. So that's I think, a little bit on this side. And then to Roger's point, I do think, I love Roger's connection detail, for example. I really admire it. But Roger, I think, is stuck in a situation that says, you know what, I've invested a lot of time in this connection detail. I need to hold on to it. Because there's no way to either make that a standard or adopt another standard. We don't have, again, which is another part of the modularization, digitalization strategy, which requires a policy framework that exists in every other industry in the US, and I just showed it with Volkswagen and Ford, and it exists in more mature off-site industries like Sweden and Japan, where innovations are not just Renaissance architect-style innovations, but are master builder-style innovations. Innovations that are innovative because they can be disruptive, which means they actually have legs to walk and change the supernormal situation on the ground. And that is something we don't teach in architecture schools, we don't discuss, but because we do not, there is a gap that once was filled by architects. So that's my thoughts on the topic.
Well, I see that both Elizabeth and Jose Luis took their mics out, so I assume you have some response?
Yes, in fact, I do. These are great comments. Yeah, it's really interesting. I teach this class called Products of Practice, and it could be called Instruments of Service. And actually, it's about how what we produce as architects in the world. Certainly, at the Renaissance, it shifted, and it's shifting all the time in relationship to society and industry. And what kind of agency, in fact, does it give us when it shifts? And we had a very interesting set of guests in the other day. One of whom was effectively making the case of the return to the master builder. It has to be vertically integrated, or there's no agency and there's no power. And the other one was actually not an architect, but was filling in the entire documentation gap, and was really, frankly, crushing it from a profitability perspective. And strangely, in that moment, I think what became clear to all of us in the room, there are about 30 of us in the room, was that the sort of historic role of the architect, which is to mediate the systemic constructs of the world, and these are things like industry standards and like regulation, and now we're accountable to things like systemic racism and justice, to mediate that into a condition on the ground, and Jose Luis, I think this could also, you could extend this and say, mediate massive data sets into an output or a condition that is, call it curated or whatever, that was kind of the only moment for that mediating opportunity was actually in the digital space. It was kind of eclipsed from a physical perspective. So this is a long-winded way of saying I totally agree. And it's a fascinating moment to be here and having this conversation, because it feels like an inflection point.
Jose, did you want to add something, or?
I always do. Well, Ivan, thanks for pointing out that also I should also be fired for historical inaccuracies. I don't know. I think there's a lot to be said also about architecture education and how certain schools or certain cultures promote a particular approach to architectural design. I was actually Googling before it came to my mind. There was this writing from this couple who were architects in the 50s who wrote this tiny manifesto with sketches called the 10 Best Principles for Architecture. I forget their names, but basically it was like 10 super simple principles of what is good architecture, and it was really simple things such as people like big windows with sun coming in, with a view to a tree, and with perhaps a fireplace, or and it's like architecture is not so difficult, at a basic level, at a human level, It's just that we are perhaps more focused or more geared towards like the singularity of architecture, like iconic image aesthetics, and that's a lot of what studio sometimes is about, et cetera, which arguably is interesting, but it's not what the core of architectural production is for the most of the world. And that also relates to the issue of data. How many singular buildings can we learn from in order to replicate those patterns? Maybe Frank Gehry has a production that is large enough so that we can turn a neural network to generate Frank Gehry-like buildings. But even if we were to do that, what's the use of that if basically ripping off Frank Gehry's style is something that is not desirable, except for Frank Gehry himself, So there's a lot of, conflicting.
So,
Could I say one more thing, Chris?
yes.
It's very interesting to me that it actually it feels like the design of the modules themselves, the details, and the voxels and the standards actually become the most important thing. That actually becomes the territory of design in this case.
Ivan's shaking his head, not me.
And Roger too. So. Yeah, because that's why we shouldn't use the word detail comes from engineering. The word subassembly comes from manufacturing. They're very different things. So when we say we should, this again, language is important. So a subassembly is it's a point in a network. So when you're thinking about a subassembly, you're thinking about labor, you're thinking about supply chain, you're thinking about the client and what they want. Whereas when as architects, we have the Renaissance, history theory idea, which is that we're going to move from something big to small or small to big, and that's really not. Right. I'm gonna get Roger to talk about it in practice. I'm just talking about it in theory. That's not how it works, and that is again back to the education of the architect. But Roger.
I think I was I was going to say it, and I'll just say it now. It's like I think what it does call for, the idea of utilizing industrialization or manufacturing in the process of creating architecture, calls for. I think to your point, Elizabeth, it calls for process, an early design integration of a system of things, including architecture, engineering, and manufacturing that is required in order to utilize it in an efficient way to create sort of the end goal, which hopefully is housing that people like to live in and cost effective. And so I think that rather than it being a limitation, it's actually an advantage of knowing where it is you're starting, as opposed to, as I mentioned earlier, that you want light switches here, and then you let the electrical engineer, after you've bought the job, figure out how to make it happen. So I think if that's what you're saying, but I don't think it's actually taking anything away. I think it's actually offering an opportunity to understand how it's manifested while it's being created conceptually.
So Elizabeth, we could go. I just want to be mindful of my role as moderator, which is to keep an eye on the clock. And so we have 15 minutes left in the panel, and there's so many things to get into. I had a couple of questions. I don't know if I have time, but I want to make sure we get people in the room engaged. So let me hold off and see if my questions come out from the audience. So folks in the audience, we have Nestor has a question up here, and then people online, and then Sean, and then David, if you got any online questions, let me know. So we got Nestor and then Sean.
Okay. Do I need a microphone for the folks at home?
Yeah, you do. I think
I'm normally loud and obnoxious, but I'm not sure I can be heard.
Here, they're coming.
Thank you. Really interesting conversation. I want to, as a lawyer in the room, thank you first for bringing lawyers into the room. I wanted to ask about the regulatory piece of this. And so I teach a class about regulation, and just randomly this week, we're looking at a proposed rule about energy conservation standards in manufactured housing. that the Department of Energy put out in August. So you know the rule, it runs about 95 pages. The overwhelming majority of the rule is not about design standards, it's not about, it's a cost-benefit analysis argument. And the overwhelming comments that came in from the industry, from advocates, were all about a disagreement about the implications on the industry and for manufactured housing as a supply of affordable housing, of the cost implications of a set of design choices. And it's got multiple tiers and it's very complicated and my students are really confused. But what makes me wonder about digitalization from the perspective of regulators is the potential, and I'm curious for all of your reflections on this, to render more kind of translatable. I mean, Jose Luis, your point about democratizing design, I wonder whether there's potential so that we're not ending up having in the pages of the Federal Register a 95-page argument about the basic implications of thermal envelopes and things that we should know something about, and whether there's potential for technology to facilitate the conversation between regulators who have their own imperatives and legislation and their own normative goals, and then people who work in this world where there seems to be some, you know, beginning last night with the complaints about liability, there is some tension here, right? And whether this is a bridge, whether technology and digitalization can be a bridge to two communities that don't really speak the same language.
Well, this is a great question. I will open up to the panel. I just want to tell folks, I want to get more voices in, so if we can have quick answers so we can get more questions. But whoever wants to jump in, there's a lot there.
I'll do a quick answer just because it's important. So I know that study, and I think I'm on the advisory board of that study. I'm pretty sure, and Ryan is too. We're on a lot of advisory boards at this point. But just at a meta level, the discussions we've been having with HUD is to say that these are all great initiatives, but we operate in a prescriptive code environment, and we think we need structural change in this country. We also need iterative change too. Moving to a performance-based code would just solve a lot of these issues. So if you want a simple answer, we should move to performance-based code, as opposed to trying to, because in a prescriptive-based code, we'll now have to prescribe more and more things, which will create more and more conflicts.
Does that answer your question, Esther? Jose, did you want to say something?
Yeah, my short answer to that would be code regulations are actually pretty straightforward to encode into computational frameworks, just because literally code regulations can be encoded into sets of rules that can be algorithmically parsed. So it's very easy to throw a building into a 3D model and have energy analysis, performance, air quality, whatever estimated, and then assess if a building is healthy enough or not to be built according to a certain standard of regulations. What I'm interested is in the future that we might see, I don't know about this, but whether can we imply or can we design regulations to make it imperative that buildings are healthy or beautiful, or, you know, this kind of qualitative metrics that we have no numbers for, that we could probably all disagree if we were to try to come up with like what a beautiful building looks like. But if we train a neural network with enough examples, and that actually comes from some kind of government, administration, whatever, if that is something that we even want to do, and that relates to my conversation or my question yesterday about what are the ethics of AI, the ones that are not quantitative, but are qualitative.
And Nestor, the benefit of being live is you can follow up afterwards and get more full answer to your question. Sophia, we have Sean Donovan had a question right here. So Sean, here comes the mic. That's why they're called mic runners.
Thanks. Sort of lifting up to the question, I think, where Nestor was going as well on what do we do about this. I'm still deeply struck by the fact that the U.S., which has disrupted so many industries, is so far behind, and what it is in particular that is holding us back. We've heard, I think, a really interesting discussion, having been a GSD student, about architectural education. What else do we need to be thinking about nationally to get there? And it does strike me, you know, HUD makes the code for a particular kind of housing, but the vast majority of housing is incredibly, you know, dispersed across the country. We're a federalist system that's very hard to change. I'm curious whether it's regulatory. Are there other problems with the industry? What is it that, as policymakers, we could do to change the context?
I mean, the very simple answer is in 3 months, thanks to Carol and a number of other participants, we have a 6-point kind of 6 areas of research that we think need to happen. But even just on the point you're saying about HUD does, manage the HUD code program, but inadvertently the HUD code program and Operation Breakthrough, which was a HUD program from the 60s, did create a regulatory framework that also governs the way that Roger ships his modules, the way that they're inspected. So it does there's a direct and indirect framework that has not continually improved. And so there's a lot we need to fix, and there is a structural problem in America, which is called American exceptionalism, which is that we can't even admit that we have a problem. It's true. So we have great software industry, we have terrible construction. Let's admit we have a problem, and others don't. And let's learn from them. And that alone, and say that we're not so different. We struggle when we show Swedish examples, and they're too socialist. And even though Sweden is actually a more market-driven construction industry than we have, they don't have public housing in the form that we have, for example. Or Japan is too different because, I don't know, it's too Japanese. And there's just a reluctance, honestly, to do comparative studies at all in this space, which is not just technological, which is not just policy, which is not just legal, but it actually combines all of those. So it's a complicated problem. We've tried to approach it simplistically. It hasn't worked. So let's try to understand it as a complex problem, and then we'll find solutions. We haven't stated the problem correctly.
Yeah, I think it's worth sort of on the pragmatic side, a couple of things. One of them is the building industry as a whole has no data. I mean, it's just a horrible data place. Try to figure out how much it costs to build a building and how many labor hours are in it. When I did it the first time, I took a certified payroll job and paid 40 people to count the amount of hours that were in the certified, and then I tried to organize it. We just have no data, and it hasn't gotten much better. So that's the first problem. So we're comparing something against nothing. And so when I talked to, and we talked about this earlier, when I talked to your climate tech funds right now, and analysts come to me and say, like, well, how much more energy do you save, or less does it cost to build a building? And I'm like, you tell me, you're the analyst. I don't have anything to compare it to. So that's a big problem, because that sort of defines how to move forward. And then on the other side, on the regulatory, all the other vested groups, on the regulatory side, the problem you outlined is incredibly important. But in addition to that, financing, buildings are huge risks if you're going to finance them. They're never on time, they're never on budget, but it continues. Manufacturing is generally on time and generally on budget, but it's complicated. It's just an industry change that needs to happen. And then the other side of it is risk assessment. I mean, if you build a modular building and stack it on site that's completely enclosed that you walk upstairs to work on, it's 10 times safer than a conventional construction project, but the insurance cost is exactly the same. So there's it's higher. It's higher. So to me, there's all of this framework of and obviously the built environment is a huge part of the economy, but also a huge necessity that we have. And all of the pieces and all of the stakeholders really need to reframe. I challenge the design, architectural, engineering side. It all needs to be reframed so that we can deliver what it is that's needed. So.
Could I also make a call for funding research that looks at what it means to create industry and design integrated, contextually relevant regulation and design, because HUD housing looks very similar across all parts of America, and it has in different eras, you can kind of obviously track it back in many, for many times, but we don't get NSF grants in this building. We should, but we don't, and we don't get funding like the fintech companies do. But there's a huge amount of value, and I think it would go a long way in terms of understanding even the value and potential of the digital twin, which José Luis is talking about, and which is the inevitable future. As much as we want to kind of push up against it as architects, it's inevitable. We're going to be able to do performance-driven codes in a heartbeat. But the real question is, who are they performing for and why? And I think we really need to look at this, and it needs substantive teams of researchers.
And every Sekisui house there are 500 million digital twins, for example. So speak about a data set that we don't have, or 500,000, sorry, 500,000 twins, that company has more data by every screw than we probably do in the construction industry of U.S. alone. So, just to put that in context.
I wonder if we don't get a lot of NSF grants because a lot of the work that we do and the contribution that we claim is not quantifiable. And therefore, it doesn't
Correct.
adhere clearly to the scientific method of sorts.
Correct. But it can be.
Yeah, so Shah, your question was one of the questions I was going to ask. I think I just want to point back to Ivan's list at the beginning about all the pieces that have to happen. So reshape regulation, rewire contracts, rethink design, change finance, improve supply chain, build in technology to the process, retrain workers. And we've been talking a lot about the design and the production part, but there's all those other pieces. And so he gave a shout out to Mary Tingerthal in Minnesota, who has a process where they're trying to build modular production capacity in Minnesota, and they're doing research alongside it to say where are the friction points in terms of regulation, in terms of training workers and the like. Because I think it's not one point, I think, there's multiple points. And architects and designers are working on this piece, but we need to be working in concert with these other parts.
If we asked more of construction, it would help offsite, just to put it rightly.
So I've got Carol Galante here. Anybody up top have a question? I got one person in the top row. I can't forget the top row. So after Carol, we'll go up top.
Thanks. So I just wanted to pick up on a couple of points, both on the regulation and back to the twins. And so I want to start with that one. Why is it that you have Autodesk, you've got computer-aided design? Why is it that the industry can't, forget the construction costs, you know what these designs are, right? We've got thousands and thousands of multifamily buildings that all are essentially engineered the same, and at least within various geographies. Why can't we digitize the design and translate that into a fabrication process for these sub-assemblies more readily than the industry has been able to do? Because that is really unlocking the digitalization. I have to look at the word to be able to say it. That's really unlocking the digitalization of design that is needed to make the manufacturing process. I mean, they do it in cars and they do it in airplanes. Why can't we do it in housing design?
I was just going to say, we got 3 minutes left. I want to get one last question in too, so just go ahead, but just try to be quick.
Before I respond, I would like to disclose that I'm a former Autodesk employee. So I think Autodesk, for example, in your example, or any large software company suffers from the same problems that the construction industry suffers, which is they have a huge inertia of how they do things. And if they kind of work, it's very difficult to steer them away from something that kind of works. It may not be optimal, it may not be efficient, it may not be reflecting the actual reality of what's going on, but it works and it brings money in. So that's one thing. And I also hear, I don't know if this is true, I also hear that here in the US in particular, there's a very strong labor force in construction that is very heavily unionized, and that they have a perception that increased amounts of software literacy and software agency may lead to their jobs being displaced. And therefore, they're very adamant to push against progress in those fronts. But I might be wrong about this. This is just something I've heard.
Also, all the design software that we use in this country is designed for our architecture students that are trained the way they're trained. And the software in other countries, guess what? It's contextual. It's trained the way that other people are trained. And you end up with a dominant player. Actually, Revit was great when I was using it in 1998 before Autodesk bought it, because it was really trying to experiment with something. Autodesk, for better or for worse, serves a client base that likes to do things the way they do, and it's architects that are trained not to think about fabrication. Developers don't want to think about fabrication because they want to be able to, change on the cost of construction as needed. Even though when we look at the cost and we look at the real costs, that doesn't save you any money. Changing from steel to concrete has not saved anyone money. But there's a standard belief that it is, and Autodesk is a tool built around that fiction, right? And so even just thinking, we're talking about vertical integration, but even without vertical integration, a company like Integra, which is really interesting, right, has brought a very different model to us and said, we're just going to make framing better. We're just going to make it more precise. And we're going to take Autodesk drawings or sketches or whatever the contractor wants to give us, and we'll digitally model the whole thing so we can, in a software that does speak to machines, but also doesn't just speak to machines. It will modularize what is inherently a very modularized system. Lightwood Frame is a very modularized system. Try doing that with concrete in Spain. It's very hard already, and they offer a service in the marketplace which is valued, even though it doesn't require the heavy capital-intensive investment that a more value-add product does. So it is an issue, and it's not just a tools issue, it's a training issue, it's a values issue, and if we keep just doing things the way we've done it over the 50 years, that construction line will keep dropping.
We're essentially out of time, but I want to give the gentleman in the last row the last question.
Thank you for the presentation and the conversation. I have just some quick thoughts on what José's response is. I totally agree that every individuals have their own definition of what is beauty, what is healthy, and those sort of things. And it's like a computer can have with the big data, with the quantity, can help us build an overall frame of what most people think about beauty is. But my question is when we are talking about some type of housing, like housing, for example, if I want to have a housing, I want it to respond to my own definition of beauty and healthy and functionality instead of thousands of hundreds of other strangers. So I'm wondering how could AI help us through that process? Because as a toddler in the architecture design field, I'm already finding it really difficult to understand my client's subjective, emotional definition of those things. How could we teach computer to respond to that?
One of the leaders in ML development these days is Pinterest, for example, because it turns out that Pinterest is a platform that, at its heart, it has curation of images as what the whole value that they bring in. Turns out that the idea that some user can curate a set of images really speaks to how machine learning is able to extract patterns and distill an idea of style or preferences in taste. Machine learning these days requires really vast amounts of data, but that is drastically changing. Over time, that is going to decrease to a point where maybe out of 2, 3, or 4 images, machine learning will be able to do good predictions on things, right? So what that means is that very, very soon, we will be able to start training our own machine learnings models specifically cater to our taste with very little input. And next time any software that you use asks you to accept telemetry, I don't know how to pronounce that, but uploading your own information to their server so that they can do analysis and blah, 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 very soon that will be actually extremely helpful so that you can train some neural networks that are actually fed on your own data and that give you suggestions based on your own patterns and what the machine is going to be learning about yourself. So I never click on that thing, but very soon, I should have added that to my prediction of whatever, but very soon, it will probably be a desirable thing if you can get away, or if you can just close your eyes to the whole issue of data privacy, what they're doing with the data, who owns it, etc., etc. But it will be very soon embedded in the tools that we use for design.
Well, I'm a bad moderator. The first panel's run over. David, shame on me, but I think I didn't want to stop the conversation midstream. Just a couple of observations on our kind of optimistic skeptic realm. I think there's a lot of reasons for optimism here. I think there's a lot of power that we've seen here, but a lot of questions that remain. And I think other issues we could have dug into were if we get to Ivan's world where we begin to integrate vertically and get economies along the whole spectrum, how do we know that those benefits will pass along to the consumer and not just reside in full stack modular? Sorry, Roger. And I think to José Luis's vision of this computer-aided design or the artificial intelligence and setting the goals is how do we make sure, apropos of Molly's talk last night, that the values that are being put in the goals are being put in. I think your image of saying you can control it, you can curate it is a good one, but I think there's too many other curators who might step in. But lots of great food for thought, really wonderful work. Please join me in thanking the panel.